Hi everyone, welcome to This Week in Space Science. I'm Michael Baltimore. I have the pleasure of being here with my good friend, Dr. Sean Cruzen from the Coca-Cola Space Science Center, where he is the director of that center. Sean, how are you doing today?
I'm very good, Mike. Thanks for having me in today. Going to be talking about some fun stuff today.
I love it. I already know one thing that's going on, and we found a rock that's moved up on Mars. We got to go after that thing and figure out what it is. Some say it's a donut, but I don't believe that for a second. We got to get into that. Want to thank all of our viewers for watching This Week in Space Science with Sean Cruzen. We're now on iTunes, so that's a podcast you can download. Our video podcast. Watch us on CSU.TV. We're on Mediacom 98 and 99. So that's our plug for our television station here at Columbus State University. And we're so glad you joined us. So today, let's jump right into our topic. There's a weird rock on Mars. We got to know more about that thing. Tell us about it. What do we know?
And maybe before I jump into this, I'll add a little context, which is people have always had strange ideas about the planet Mars.
Mars.
I mean, Schiaparelli and Percival Lowell, they thought they saw canals up on Mars, and they imagined intelligent life. William Herschel himself thought he saw oceans on the planet Mars. There was that face on Mars, which turned out to be just a butte. People have thought they've seen pyramids on Mars. H.G. Wells wrote that book about Martian invasion. And you know, I think the word Mars just captures people's imagination anyway. So anytime the word Mars comes up, people are predisposed to some pretty crazy notions about what can and can't happen with that red planet up there. Now, one of the interesting things that keeps going around every year is this thing called the Mars hoax. And
really?
You may have gotten this in your email, which is, hey, Mars is going to be closer than it's been in 60,000 years. In fact, it's going to be so close to the Earth, it's going to appear as large as the full moon in the sky. Have you seen that email going around?
I haven't particularly, but it sounds interesting.
Well, it turns out that there was a close approach of Mars that took place in August of 2003.
Okay.
And so every year since then, this email has gone around saying basically the same thing, that Mars is going to be super close, but it keeps getting embellished, and Mars keeps growing in the estimation. And so this is what's now come to be known as the Mars hoax. Mars will not appear as large as the full moon in our sky ever unless something has really gone off the rails with the entire solar system. So first of all, I just want to just preface all I'm about to say with all these weird kinds of things that people think they have seen either on the Martian surface or in your email box or any kind of weird stuff with Mars, all right?
There is a lot going on with Mars. I mean, the mythology of that. But we love to write about Mars.
Mars
and we've been
captures our
invaded.
imagination.
We've been invaded by Mars numerous times.
That little Marvin the Martian guy from Bugs Bunny. I think it's his fault. But for whatever reason, Mars captures our imagination. So let's go in with that context, and then we'll go take a look at something that was discovered by the Mars exploration rover called Opportunity. First, let's talk about Opportunity. So Opportunity itself has been up on the planet Mars for 10 years.
10 years. That's a good lifespan right there.
A decade of operation when it was only supposed to last about 18 months. That was the operational outlook for this thing. So it was supposed to last a very short period of time. And the thought was, well, the Martian dust storms are going to cover up the solar panels. As you look at this picture right here, the kind of flat part that you see in the middle, those are solar panels, and so the sun needs to shine on those panels in order for the rover to generate power.
Now, I don't want to jump into the story in the future, but that picture right there, there's a big rock right by the front wheel of that rover. I don't know what that means, but maybe has some relevance as we go further.
That one was an artist's concept, and so that was just kind of what an artist imagined that the rover would look like.
Just thinking ahead. Just thinking ahead.
But these Martian winds, anyway, they clear off that solar panel. So this thing's gone for 10 years. An amazingly successful mission for NASA, gone far beyond, and made a huge number of discoveries in the period of time after which it was supposed to have ceased operation. So that's an important part of this story. So this is an incredibly successful scientific instrument driving around up on the surface of another planet. However, the discovery that it just made is weird enough that it might rank among the very most important discoveries ever made by the rover. Now, there's going to be two weird parts of the story, and obviously we're just going to jump right in with the first weird one, which is this. It photographed the ground one day, and it saw the ground looking a certain way. Then it photographed the ground 12 Martian days later, and there was a rock there that wasn't there, in the prior photograph. So here we go. As we see the ground in the left-hand side, these are two different pictures. And the word, the word sol, S-O-L, just is, that's a Martian day, all right? So sol number 3,528 on the left-hand side.
Okay.
That's Opportunity rover's 3,528th day on the Martian surface. Those are Mars days, okay? So as it looks at the ground right there, you see kind of an indentation sort of near the center, but nothing rock-like there. But then look at the right-hand image. 12 Martian days later, and remember, a Martian day is a little longer than an Earth day. Okay. 12 Martian days later, you see a rock that has been described looking something like a jelly donut, which just makes me hungry as I sit here and contemplate this image now.
I like that image right there, but wait.
Powder sugar, maybe?
I know, but we're all thinking
Jelly
this, though. We're all thinking, we can imagine what that's like, but how did that rock get there?
That's
what
really
we
the
want
question,
to know.
isn't it?
That's where we want to go.
Maybe $10 million question. Where did that rock come from? Now, of course, the staff at the Science Center, when we saw this picture, we all gathered around someone's computer and we were looking at this picture together. And the thought came to mind, obviously, there must be Martians, right? And so what does any 7-year-old boy do when he sees some weird object out in the desert he doesn't know what it is? Picks up a rock and throws it at it, right? So it must be these Martians, maybe juvenile Martians, saw this rover out there and said, what is that? I don't know. Let's throw a rock at it and see what it does. Threw the rock, landed in front of the rover, and now you have the scientific mystery. So that's one model.
Yeah, that's one.
It's not a very widely accepted model,
but it could be others.
Around the Science Center here at CSU, that one's been suggested.
Okay.
Now, Dr. Steve Squires, who's at Cornell, he's actually in charge of the science missions with these exploration rovers. He has a couple of different ideas that he announced in a press conference about this, or a talk about this. Okay. And his concepts came down to two possibilities. Number one, that somewhere nearby there was some sort of an impact on the surface of Mars from a meteorite, from space. Okay. Remember, the Martian atmosphere is much thinner than the Earth's atmosphere. So if a rock does enter the Martian atmosphere, it's far more likely to make it all the way to the ground and cause an impact crater. So if some sort of impact happened reasonably nearby the rover, it may have thrown debris which then landed near that rover on the ground of Mars, and all of a sudden you have a rock there. Okay? So that's one idea. A second idea is that the rover itself, as it was driving around, kicked up the rock and it threw it to the position where it photographed it later. Now,
that's where I'm at. I think that's what happened. This is my theory. It has zero credibility, but that rover's got how many wheels on it?
It's got six
wheels, and those wheels are spinning around. Something gets, just a right angle, flies up, it lands there. That's what I'm going with.
I'm going to add credibility to your idea. Okay, good. Because that's what Steve Squires said probably happened also.
Oh, Steve and I. All right, there we go.
Steve and you are just simpatico on that idea.
I'm glad. I'm glad.
So the notion is it could have been the rover. Now remember, this is a remote control car driving around on the surface of another planet, but it's not necessarily like the ones you'd pick up at Radio Shack where you're spinning rooster tails and burning out and doing all kinds of crazy stuff. They drive these rovers very slowly. However, the rover's heavy. And so it weighs a fair amount. So if it were to drive over the top of a rock that was sitting just right, that rock may very well squirt out. It's not the speed of the rover, it's the weight of the rover and the position of that rock that might cause it to jet out, 7, 8 feet, 3 meters, somewhere along that, away from the rover. And so that's the idea. That's probably what happened. And of course, certainly, a rock appearing out of nowhere on a dead world seems pretty unusual.
Really?
But that is actually not the most unusual story.
Oh.
This rock has a far more unusual story to it, which is this. Obviously, the next Martian day, after the controllers on Earth saw this weird rock appear, they went back and they took a closer look at this rock. And I think maybe we even have some pictures of them taking a closer look. So the boom arm on the rover, they lowered it down to where they can get really close views and get the instruments of that rover taking close looks at this rock right here. And you see that boom arm shadow right there. Here it is. It's extended forward. It's moving down toward the rock, and they're going to get some very close-up images and some other sensing equipment on this rock.
Yeah, Sean, give us an idea. Do we know the size and what we could compare that to? How big is this rock?
They called it a donut because it's about the size of a donut. So you can imagine, the size of your fist or a little bit bigger is about how big that rock is. And you saw in that last image, they had the instruments right down on top of it. Well, from that distance away, on that boom arm off the rover, they can actually put their spectrographs to work, and they can start to figure out what this rock is made from.
I need to go back and look at those pictures too. James, could you bring us back to the one, and even the one before with the two shots there? Yes.
Got that boom arm sitting down there. They're moving those instruments into close range where they can get both close-up photographs and some of the other sensors in place to do some serious analysis on this rock. And the interesting thing is this. It appears that the rock has an extremely high content of 2 elements. One is sulfur.
Okay.
2 is magnesium. So this rock appears to be extremely rich in sulfur and magnesium compared to not only rocks around it in that general area of Mars, but any rocks that have ever been discovered or analyzed on the surface of Mars.
There we go. Now it's getting interesting, isn't it?
So this is the weird part to me. This rock really does look very chemically different from any rocks that have ever been analyzed in detail on the surface of Mars. And now, so what happens next? Well, space scientists and planetary geologists will begin to piece this piece of evidence together and figure out what that means. One of the things I think I would do if I was in charge of driving the rover, I would back it up and look at where the wheels had been digging to see if there's more specimens of this similar kind of variety.
Yeah, that's a great idea right there. You want to know what the possibilities are that if it did run over a particular rock with the weight that you were talking about, and it kind of sheared it and it just flew off, then at that spot, we want to know. That's a very good idea.
And I would imagine that's exactly what the scientists in charge of this rover project are doing. But again, it's not an RC car. There's not somebody with an Xbox controller driving the wheels around and making this thing move. They have to actually submit a set of programs to the rover to control it. So that they would have to, in order to carry out that observation I was just talking about, they would actually have to pause the current programming of the rover, feed it some new instructions, and then have those new instructions to where it would back off and be able to examine that part of the surface. I wouldn't be at all surprised if that's what they end up doing, because that's a very, very interesting find. The fact that it's so chemically different. It's not just that a rock appeared. It's that a rock appeared that is so very different from the rocks around it that it makes it extremely interesting from a geological perspective. So look for more analysis of the weird donut rock. By the way, the rock has a name. It's called Pinnacle Rock.
Okay.
So look for some
It's
more
better
detail.
than donut rock, I think, but
well,
still,
I don't know. Donut rock has a way of sticking with people, I think.
That's it, maybe so.
But look for some more detailed analysis of Pinnacle Rock coming from the Mars rover team in the near future.
All right, we're going to hear more about that. There's no doubt about it when something like that happens. But we are moving those rovers around up there. Anything can happen, I would imagine. All right, so I understand there's a new star in the galaxy out there, and at least a nearby galaxy.
Yeah, there's at least a new star that we can see.
Okay, all right, good.
A galaxy that is 11.2 million light years away. Now let us remind ourselves that a light year is just a little bit more than a regular year. No,
yes, I would think so.
Anyway, so a light year is about 6 trillion miles. So it's a unit of distance. It's not a unit of time. It's measuring how far light can travel in 1 year, which is just short of 6 trillion miles. So it's 11 million times 6 trillion miles away. So this galaxy is very, very distant.
Out there.
However, among galaxies, it's reasonably nearby. So when you compare that with the distances to other galaxies throughout our entire universe, this happens to be one of the more nearby galaxies. That's just telling you that the universe is a really big place, and space is very, very empty. There's not a whole lot of galaxies just compacted around our own Milky Way. They tend to be very spread out. So this galaxy is called M82. It's Messier 82 out of the Messier catalog. Here's some pictures of it, taken on the left-hand side from the National Optical Astronomy Observatory, and that's in visible light. Taken on the right-hand side from the Spitzer Space Telescope, that's an infrared light. You can see that the galaxy has a giant infrared glow around it. It is a peculiar galaxy. In other words, it's probably something like a galaxy merger or some kind of a galaxy interaction taking place where you have a whole bunch of gas out there creating that red halo. But that's a topic for another day.
Right.
Because what we really want to point out is in neither of these two pictures or in any of the other pictures that are regularly taken of M82 was a new star observed until this next photograph was taken. And there it is right there.
Okay.
So this was taken just a few days ago by a professor named Steve Fossey from University College London, along with a few of his astronomy students who are listed on the screen right there.
Okay.
They were out actually doing an intro astronomy class and doing a project where they were observing galaxies with a small telescope.
Sure.
They took this photograph and they said, hey, that bright dot there, you can see it marked with the 2 white lines. That bright dot, that shouldn't be there. We don't see that in any of the other photographs that were previously taken of this galaxy. What is that? Well, and Steve Fossey being a bright enough professor, he said, hey, that could actually be a supernova. So that, believe it or not, there's a hotline to call. It's the International Bureau of Astronomical Telegrams.
Okay, now that is amazing news right there for a lot of us. There is a hotline to call about objects in space.
There's a place to phone.
I love it. I love that idea. Well, so he made the call,
right? You think that
right?
you have discovered a brand new object in outer space, a new asteroid, a new comet, a new supernova going off, there is a place to contact.
Love it. I love
It's the
that.
International Bureau of Astronomical Telegrams, and you can report your first sighting of this new object. Well, that's what they did. They reported that sighting, and then right then, the Bureau for Astronomical Telegrams puts out a message to astronomers all across the world, saying, hey, we have a credible report of what could be a new object appearing in the nighttime sky.
Okay.
Please observe the galaxy M82 and see if you can see this object. So astronomers did that, and they began to photograph what is clearly now known as a supernova explosion taking place in the galaxy M82. Here's the thing, M82, 11.2 million light years away, it's close, but it's not close enough for us to easily be able to see individual stars through telescopes of the size of these kinds of things.
Okay.
In fact, through almost any telescope. So the notion is, if one new star appears and it's in that galaxy, that means it must be much, much, much brighter than any of the stars around it. And in fact, supernova, when they go off, that's a star reaching the end of its lifetime and exploding. Supernova, when they go off, can outshine the light from all the galaxies in their parent galaxy, all the stars in their parent galaxy. Let me say that again. So one star, when it explodes, can shine with the light of all of the other stars in that galaxy combined. And that's why you can see a single star sometimes in a distant galaxy. It's because it's gone through this death throes of explosion, and it's shining very brightly for a period of about 2 weeks. And then that star will fade, it will lose that light, and you won't be able to see it anymore. So,
and they've got to make sure that that star is in that galaxy. It's not out in front of the galaxy or behind the galaxy, because it could be very bright and kind of be not connected to necessarily. So they got to do those measurements as well.
All true. And so there's a variety of processes that they do to verify that that star is in fact part of that parent galaxy. And one of the things they do is they do a survey of faint stars in our own galaxy, because it could be like bugs on the windshield. It could be a nearby star that something's going on.
Right.
However, when supernova explode, the way that their light changes over time makes a specific shape on a graph called a light curve. And that light curve, once we start plotting the way that light is changing, the intensity from that object is changing in time, we can then use that to identify it as a supernova. And once we know it's a supernova, we know it can't be, if it's only that bright, it can't be in our own Milky Way. It has to be very, very distant. So that's one of the quick verification processes that is used to say, yes, that is an exploding star in that distant galaxy, because the light curve tells us that it's about at that same distance.
Now you mentioned this is a type 1A. I'm assuming by that statement that there are categorization of the supernova, and how do we, how that goes in terms of the size and so forth. Could you talk a little bit about this, that typing of it, or 1A?
So there are two fundamental types of supernova explosions. One has to do with a very large star reaching the end of its life cycle, using up all of that hydrogen fuel that it keeps itself going with in its core, and then the whole thing collapses, it explodes, and it makes a powerful explosion with all kinds of light. That is called a type 2 supernova. That's what we think of as kind of a classical supernova model, and it only happens in the most massive stars that are much more massive than our own sun. But there's another weird thing that can happen, and it can involve stars like the sun that happen to be in binary star systems. And so if you think about two stars orbiting around each other, one star goes through its life cycle and fizzles out, and the core of that star becomes what's known as a white dwarf. Now that's effectively a dead star, but there wasn't really an explosion involved with that. However, that white dwarf star core is still orbiting around this companion star. So when the companion star starts to die off also, assuming they're about the same age because they were in company together, so when that companion star dies off, its outer layers of its atmosphere begin to expand. Then the white dwarf begins to draw material off that other star, that neighboring star, and it can grow in mass. And it goes through a whole variety of flaring up episodes. We call those novae, not supernovae, but novae. Okay. And so if the star goes through a nova episode, it can a change in brightness. However, when that star gains enough mass that it actually passes a certain limit called the Chandrasekhar limit, that's 1.4 times the mass of the sun. Right as soon as it draws 1.4 solar masses, it explodes.
Okay.
That is what a type 2 supernova explosion is. It happens at a very specific mass. So these types of supernovae are generally about the same brightness. Because they're generally about the same brightness, then anywhere we see one of those kinds of supernova exploding, we know about how bright it really is. And so how bright it looks to us, and knowing how bright it really is, helps us determine how far away it is. We call that a standard candle.
Okay.
So type 1A supernovae have been used as a standard candle to measure the distances to their parent galaxies, the galaxies in which they occur. And that has been a very important tool for astronomers to help them nail down the size of the nearby universe, or even much more distantly, the observable universe. But not only that, it's helped astronomers to tie down a very important fact, which is how fast those galaxies are receding away from us. In other words, how fast the universe is expanding.
And it's consistent with this too. So we can use that as a standard and to make these measurements.
We can. And maybe the most interesting part about that is when supernova type 1A were really used to recalibrate the distances to distant galaxies back in the late 1990s, that led to a very important discovery, which was by observing the most distant galaxies and knowing how far away they were, we could tell that their rate of expansion, how fast they're moving away from us, was actually increasing. In other words, they were accelerating. They were speeding up as they were moving away from us. That violated any model of cosmology, of the way that the Big Bang functions that was known at that time. And so that led to a whole new concept that we today call dark energy. So it was in fact the discovery of type 1A supernovas and using them as standard candles and using that to measure the distances to the most distant galaxies in the universe that led to this weird concept that the universe is actually accelerating its expansion, and the driving force behind that must be this weird stuff called dark energy. Now, what is dark energy? We haven't really nailed that down yet. That's still just a name given to this phenomenon that's taking place, but that's what scientists are working on now. And it was all because of these type 1A supernovas being discovered and used as standard candles that we had that measurement. Now, the supernova that just went off is the nearest type 1A supernova ever discovered. And so that is going to allow astronomers to recalibrate their standard candle that they've used to measure the distances to all these other much more distant galaxies. So this supernova may actually have implications for what we understand about the size and nature of the entire universe. That makes it an extremely important supernova discovery in M82 by the folks from University College London.
Wow, and that was an introductory class out looking for that, as a matter of fact. So it doesn't have to be these advanced scientists with many, many years of experience. It could be the kid looking through that telescope that discovers and making that phone call, now that we know that there's a phone number out there.
You know, that's one of the intriguing things about astronomy is that amateur astronomers have in the past and still continue to make very important contributions in the field of astronomy because there's one simple fact: the sky is very, very large. It's hard for professional telescopes to monitor the entire sky. They just don't have enough spatial coverage to monitor everything that's happening in the sky all the time. So it's important for amateur astronomers to be aware of what they're looking at and be able to report strange phenomenon that they observe to places like the International Bureau for Astronomical Telegrams, so that professional astronomers can jump on those stories right away. And amateur astronomers have discovered a variety of comets, asteroids, supernova, and phenomenon, even impacts on the moon recently. And so these are all interesting phenomenon, first reported by amateur astronomers, then further pursued by professional astronomers, that are really important contributions to science.
I love it. Ladies and gentlemen, this may be one of my favorite shows today. We just ran through a lot of things, and we touched on dark energy. We talked about supernovas, and we started our show with the Pinnacle Rock, or as you said, the Donut Rock.
Powdered sugar donut.
The powdered sugar donut rock on Mars. How cool is that? Ladies and gentlemen, thank you for tuning in to This Week in Space Science. I'm Michael Baltimore. Happy to be here with Dr. Sean Cruzen, the Executive Director of the Coca-Cola Space Science Center. We do this show every week on CSU TV. Join us each week for Twiss, This Week in Space Science. We'll see you next time.